Welcome to this presentation. In this presentation, let us see about the maxima and minima direction of 2 point sources with equal current in magnitude and phase, and then currents equal in magnitude but out of phase. So to find the maxima direction, we know that the total electrical field is given by, as we have seen in the previous presentation, it is equal to 2 E naught into cos of beta d cos phi by 2. Okay, so to find the maxima direction, the total field will be maximum when cos of beta d cos phi by 2 is maximum. So as we know, the variation of cosine of an angle is plus or minus 1, and hence the condition for maxima is given by cos beta d cos phi by 2 is equal to plus or minus 1. Let the spacing between the 2 point sources be lambda by 2. Then we can write cos beta into lambda by 2 cos phi by 2 is equal to plus or minus 1. So when you substitute the values of beta as 2 pi by lambda, and since we have assumed that the distance between the two sources as lambda by 2, so we can substitute, and lambda will get cancelled and 2 will get cancelled. So it becomes, the equation becomes cos of pi by 2 cos phi is equal to plus or minus 1. That is, pi by 2 cos phi max is equal to cos inverse of plus or minus 1. That will be equal to plus or minus np, where n is equal to 0, 1, 2 and so on. If n is equal to 0, then pi by 2 cos phi maximum is equal to 0, which means that cos phi max is equal to 0. So when we cos phi max will be equal to 0 when phi max is equal to 90 or 270 degree. So the maxima occurs in two angles, that is at 90 degree and 270 degree will get the maximum radiation. And now to find the minimum radiation, that is the minima direction, the total field strength will be minimum when cos of beta d cos phi by 2 is minimum, that is equal to 0, as cosine of angle has minimum value of 0. Hence the condition of minima is given by cos of pi by 2 cos phi minima is equal to 0. So as we substitute the values of d is equal to lambda by 2 and beta is equal to 2 pi by lambda. So this equation becomes pi by 2 cos phi minima will be equal to cos inverse of 0, that is equal to plus or minus 2n plus 1 into pi by 2, where n is equal to 0, 1, 2 and so on. If n is equal to 0, then pi by 2 cos phi minimum is equal to plus or minus pi by 2. And cos phi minimum is equal to plus or minus 1 because both pi by 2 will get cancelled. So now phi minimum will be equal to 0 or 180 degree. So this equation shows that the minimum direction, that is at a 0 angle and 180 degree angle, there won't be any radiation, that is minima direction. And next we will find the half power point direction. When the power is half, the voltage or current is 1 by square root 2 times the maximum value. Hence the condition for half power point is given by cos of beta d cos phi by 2 is equal to plus or minus 1 by square root of 2. Let d is equal to lambda by 2 and beta is equal to 2 pi by lambda, then we can write cos of pi by 2 cos phi is equal to plus or minus 1 by square root of 2. So that is equal to pi by 2 cos phi is equal to cos inverse of plus or minus 1 by square root 2, that is equal to plus or minus 2n plus 1 into pi by 4, where n is equal to 0, 1, 2 and so on. So if you substitute n is equal to 0, then pi by 2 cos phi HPPD will be equal to plus or minus pi by 4, and cos phi HPPD will be equal to plus or minus 1 by 2 because pi and pi will get cancelled and 2 and 4 will become 1 by 2. Okay, so cos HPPD is equal to cos inverse of plus or minus 1 by 2. So this value it gives as 60 degree or 120 degree. So the half power points are in between 60 or 120 degree. So this diagram shows the field pattern with the ET against phi for d is equal to lambda by 2. Then the pattern is bidirectional. And next let us see about the 2 point sources with currents equal in magnitude but opposite in phase. Let us consider 2 point sources separated by distance d and supplied with currents equal in magnitude but opposite in phase. So consider the same figure that we have seen already. So all the conditions are exactly same except that the phase current is opposite, that is 180 degree. With this condition, the total field at the far point P is given by it is equal to minus of E1 plus E2. Assuming equal magnitudes of currents, the fields at point P due to the point sources A1 and A2 can be written as E1 is equal to E0 into E power minus j psi by 2 and E2 is equal to E0 into E power plus j psi by 2. Substituting the values of E1 and E2 in equation 1, we get it is equal to minus E0 into E power j psi by 2 minus j psi by 2 plus E0 into E power plus j psi by 2. So when you take E0 outside, the equation becomes E0 into minus E power minus j psi by 2 plus E power plus j psi by 2. So rearranging this term, that is when we multiply and divide the equation by 2j to convert it into trigonometric form, the equation Et will be given by 2j into E0 into E power j psi by 2 minus E power minus j psi by 2 by 2j. So this term that is given in the bracket can be written as sin psi by 2. So by trigonometric identity, we know that e power j theta minus e power minus j theta by 2 can be written as sin theta by 2. So that equation becomes it is equal to 2j into E0 sin of psi by 2. So now as the condition for 2 point sources with currents in phase and out of phase is exactly same, but the phase angle can be written as in the previous case. Phase angle is equal to beta d cos psi, and substituting the value of phase angle in this equation, we get it is equal to 2j E0 into sin of beta d cos phi by 2. And now let us find the maxima direction for the case, and there are 2 point sources with currents in equal magnitude but out of phase. So from the equation which I have shown for the value of beta, the total field will be maximum when sin of beta d cos phi by 2 is maximum, that is equal to 1, as the maximum value of the sin angle is plus or minus 1. Hence condition for maxima is given by sin of beta d cos phi by 2 is equal to plus or minus 1. Let the spacing between the two isotropic point sources be equal to d is equal to lambda by 2. Substituting d is equal to lambda by 2 and beta is equal to 2 pi by lambda in this equation. So we get sin of pi by 2 into cos phi is equal to plus or minus 1. So when you take when you remove the sin terms, that is the sin of theta will be equal to plus or minus 1 for the values of 2n plus 1 into pi by 2. So pi by 2 cos phi is equal to plus or minus 2n plus 1 into pi by 2 when n is equal to 0, 1, 2 and so on. So if we substitute n as a 0, so if n is equal to 0, then this equation becomes pi by 2 cos phi maximum is equal to plus or minus pi by 2. Because when you substitute n is equal to 0, this 2n term will get cancelled. So 1 into pi by 2 will become as pi by 2, right? So this pi by 2 and this pi by 2 on the left hand side and right hand side will get cancelled. So cos phi maximum will be equal to plus or minus 1. So phi max will be equal to 0 or 180 degree. So from this equation, we can understand that the maxima direction occurs at angle 0 degree and 180 degree, right? So again now to find the minima direction, again from the equation, the field strength will be minimum when sin of beta d cos phi by 2 is minimum, that is equal to 0. So hence the condition for minima is given by sin of beta d cos phi by 2 is equal to 0, and assuming that d is equal to lambda by 2 and beta is equal to 2 pi by lambda in this equation, we get sin of pi by 2 cos phi is equal to 0. So pi by 2 cos phi will be equal to plus or minus n pi, where n is equal to 0, 1, 2 and so on. So if n is equal to 0, then pi by 2 cos phi maximum will be equal to 0. So when we take pi by 2 at the right hand side, 0 by anything is 0. So cos phi maximum is equal to minimum is equal to 0. So when you take cos inverse of 1, so phi minimum will be equal to plus 90 degree or minus degree. So from this equation, we can realize that the minima occurs at the angles plus 90 degree or minus 90 degree. When the power is half of the maximum value, the voltage or current equals to 1 by square root 2 times the respective maximum value. And hence the condition for the half power point can be obtained from that equation as sin of beta d cos phi by 2 is equal to plus or minus 1 by square root of 2. So d is equal to lambda by 2 and beta is equal to 2 pi by lambda, and we can write sin of pi by 2 cos phi is equal to plus or minus 1 by root 2. So pi by 2 cos phi will be equal to plus or minus 2n plus 1 into pi by 4, where n is equal to 0, 1 and 2 and so on. And if n is equal to 0, we can write the pi by 2 cos phi HPPD will be equal to pi plus or minus pi by 4. That is, when n is equal to 0, this term will get cancelled. So 1 into pi by 4 gives you the value of pi by 4. And this pi and pi will get cancelled, and if you cancel 2 and 4, the equation becomes cos phi HPPD is equal to plus or minus 1 by 2. Therefore, phi HPPD is equal to 60 degree or 120 degree. Thank you.